When winter arrives, the ecosystem shuts down almost overnight. As the temperature drops, the steady supply of leaves, fruits, and insects simply vanishes. For mammals, this is a massive physiological problem. To keep a warm-blooded body functioning, pumping blood, inflating lungs, and generating internal heat, an animal requires a continuous, non-stop intake of calories. This diagram illustrates the harsh math of the season. We have a high, unyielding baseline energy demand on one side of the equation, colliding with a food supply that drops to near zero on the other. For a woodland creature, the arrival of snow marks the start of a lethal starvation event. Some animals solve this deficit externally. Birds fly south to follow the food, while squirrels rely on massive caches of nuts they've hidden away. But mammals like groundhogs and dormice are tethered to their frozen habitats without a hidden pantry. To stay alive, they must rewrite their internal rules of survival. They undergo a highly calculated total physiological shutdown, the ultimate biological override designed to cheat starvation. The process starts weeks before the first frost. Prompted by the changing daylight and dropping temperatures, these animals enter a state of frantic activity. This graphic shows the gorging phase. The animal consumes huge quantities of whatever food is still available, and its body rapidly converts those calories into an expanding, dense layer of adipose tissue, or fat, right beneath the skin. With their internal storage topped off, they retreat into dark, insulated spaces. They burrow deep into the soil or tuck themselves into caves, establishing a secure perimeter against predators and extreme weather. Once they seal themselves in, that layer of fat becomes their entire fuel tank. It has to last the rest of the winter. Entering hibernation is distinct from the standard mammalian process of falling asleep. Normal sleep is actually quite energetically expensive. A sleeping mammal still burns a significant amount of fuel to maintain its core temperature, lung rhythm, and blood flow. This dashboard compares normal sleep to hibernation. While a typical sleeping animal maintains a high temperature and rapid pulse, a hibernating animal throttles its internal engine all the way down, allowing its core body temperature to plummet until it nearly matches the freezing burrow around it. Look closely at these specific metrics for a groundhog. Its heart slows to a crawl, beating just 5 times a minute, while its breathing drops to only about 2 breaths per minute. Secondary biological functions shut off entirely. Depending on the species, the animal may not urinate or defecate for weeks or even months at a time. By paralyzing these normal bodily processes, the animal reduces its daily energy expenditure down to a tiny fraction of its normal waking rate. They place themselves in a state of suspended animation, allowing them to stretch what would normally be a few weeks' worth of fat reserves across several brutal months. As the snow piles up above ground, the months drag on. Below ground, the animal's thick layer of stored fat is slowly, steadily burned away to maintain those minimal life support functions. This line graph illustrates the exact biological timing required to survive. The steady downward slope of the animal's fat reserves must intersect precisely with the warming temperatures of spring. As the dirt begins to thaw and that internal fuel gauge nears empty, a physiological trigger fires. The animal's heart rate and breathing rapidly accelerate back up to their waking baselines. By the time the creature emerges from its burrow, the plants and insects have returned, finally resolving the impossible energy equation of the winter. Hibernation is a biological descent to the very edge of death. It is an involuntary, extreme survival state that bears little resemblance to rest. It is nature's way of hitting the pause button on an animal's life, allowing them to outlast an environment that would otherwise destroy them.